This tutorial will be about definite and indefinite integrals. The difference between a definite integral and an indefinite integral is that a definite integral contains limits, and an indefinite integral has no specified limits for the integration, so there are no boundaries. And when given a graph like this, and this function here with the limits from A to B, you want to find the area, which is this, this, and this. So this is a definite integral because it contains limits. The equation to find the area of a definite integral is the antiderivative of A and B equals f of B minus f of A. That's to find the area of this. For an indefinite integral, the equation is a lot more simple because it contains no limits. So it would just be the antiderivative of f of x dx. That would be your indefinite equation. And a few examples to show what I'm talking about. We'll start with the indefinite problems. So this one is very simple. The antiderivative of sine of x dx. So what you do here is you have to work backwards. Sine of x, the antiderivative of sine of x is negative cosine of x. Okay? Plus c. You get negative cosine of x plus c because when you derive negative cosine of x, you get sine of x. So this is what I mean when I say working backwards. This one is just one problem, very simple. Another problem here is also very simple. It's just a little longer, but it's easy. X cubed plus x squared plus x dx with respect to x equals, okay, so what you do here to find the antiderivative is you could do is add a 1 to your exponents, so it'd be x4, and divide by what you get over 4. Do the same here, plus 1 plus x cubed over 3 plus x squared over 2 plus c. If you want to make sure that you've done this correctly, just derive. So you bring down the 4 forward, 4x cubed over 4. The 4's cancel out, you get x cubed. You do the same here, you end up getting the same equation that you got here. That's another example, very simple. Let's move on to the definite integrals, and like I said, these have limits, and so the equation from A to B, f of x dx equals f of B minus f of A. That's the equation. So given the example, okay, the antiderivative of 2x plus 3 from 1 to 3 equals, okay, the first step is to antiderive 2x plus 3. 2x plus 3, the antiderivative of that is x squared plus 3x. You're not done because you still need to plug in these values. So in order to show that, you put this line right there with your values from 1 to 3. And now what you do is you plug in, like it shows here, f of b minus f of a. This is your b, this is your a. You plug those into your f of x, which would be this. So it's 3 squared plus 3 times 3 minus 1 squared plus 3, 1. Okay, 9 plus 9 minus 1 plus 3. So this is 18 minus 4 equals 14. That would be your answer. Okay, we're done with that. The second problem here, it looked a bit difficult at first when I looked at it because it contained trig functions, but it really wasn't difficult when I solved it. So it's pi over 2, the antiderivative of sine of x, with these pi over 2 and 3 pi over 2. And again, antiderive this is negative cosine of x (3 pi over 2). And you plug these values in, so it'd be negative cosine of 3 pi over 2 minus negative cosine of pi over 2. And negative cosine of 3 pi over 2 is 0, minus negative cosine of pi over 2 is 0, leaving you with 0. That's your answer. Simple. Okay. The final example here isn't difficult, but it's a little bit more work, and this is still a definite integral. And what they give you here is, okay, when they give you g of x equals x squared plus 3x minus 5, and they give you f of x equals g prime of x, and they want you to solve for this. They want you to solve for f of x with respect to x. Okay, so they want f of x here. This says that f of x equals g prime of x, but they gave you g of x. To find g prime x, you have to derive g of x. So when you derive g of x, g prime of x equals 2x plus 3. That's easy. You plug this into here, and you get okay, now you would have to antiderive, giving you x squared plus 3x. You're not done, so you set it up. Okay, I'm going to move on down here. You plug these functions into here, giving you 5 squared plus 3 times 5 minus 1 squared plus 3 times 1, and you solve 25 plus 15 minus 1 plus 3. 25 plus 15 is 40 minus 4, giving you 36. This would be your final answer, and that's it for all the examples. I hope that everyone has learned a little bit or understood a little bit about definite and indefinite integrals. These are very simple examples, but I mean, it will get harder, so I hope that you could use these skills to apply it to a lot difficult problems.